Hi all, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic Dijkshtra algorithm. Let's dwell into the topic. So, Dijkshtra algorithm, the introduction being, this algorithm allows us to find the shortest path between any two vertices in a graph. It will provide the solution to the single source shortest path tree problem in the graph theory and also in mathematics. It is the solution to a single source shortest path tree problem. It differs from the minimum spanning tree because the shortest distance between two vertices might not include all the vertices in the graph. It works on both directed and undirected graph. However, all the edges must have non-negative weights. So this is the main thing. So Dijkshtra algorithm was developed by a Dutch computer scientist programmer. He is a software engineer, he is a system scientist, he is an essayist and pioneering in computer science. So let's see what is Dijkshtra algorithm. The algorithm maintains a set of visited vertices and a set of unvisited vertices. It starts at the source vertex and iteratively selects the unvisited vertex with the smallest tentative distance from the source. It then visits the neighbor of this vertex and updates the tentative distances if a shorter path is found. This process continues until the destination vertex is reached or all the reachable vertices have been visited. So this is the main thing of Dijkstra's algorithm. So what would be the need for Dijkstra algorithm? So the need for Dijkstra algorithm arises in many applications while finding the shortest path between 2 points. To find the shortest path between 2 points is a very crucial thing. So for example, it can be used in the routing protocols or for computer networks and also used by map systems to find the shortest path between the starting point and the destination, as how we use Google Map, or you can say how does the Google Map work using these algorithms. So a Dijkstra algorithm can work both on directed and as well as undirected graphs. As this algorithm is designed to work on any type of graph by whether it is directed or undirected. So in a directed graph, each wedge will have a direction indicating the direct of travel, and in an undirected graph, the edges have no direction and the algorithm can traverse both forward and backward. So let's see the approach that is used in dynamic programming. Mark the source node with the first step is you have to mark the source node with the current distance of 0 and the rest with infinity. Set the non-visited node with the smallest current distance at the current nodes. For each neighbor n of the current node, add the current distance as the adjacent node with the weight of the edge connecting. For example, here from 0 to 1 or 1 to 2. Mark the current node 1 as visited. Again, repeat the steps again to find until all the nodes are visited. So for example, let us consider let us see the algorithm here. So weighted graph G is given, V of E and V denotes the vertices and the edge is denoted by E. So a student wants to go to school in the shortest possible way. She knows some roads are heavily congested and it is difficult to use. In Dijkstra algorithm, this means the edge has a large weight or the cost and the shortest path tree found by the algorithm. It will try to avoid edges with larger weights. If the student looks up directions using a map service, it is likely that they may use Dijkstra's algorithm. For example, the shortest path which could be found using Dijkstra's algorithm for this particular diagram would be f of home to 3, 6, 5. So she can reach the school. So the implementation, suppose distance BB, source BU and the cost BC. So if we implement using the greedy method in 2 steps, step 1 will be you have to find D of U that plus C of U comma V. D of U is nothing but the distance between the H 1 to 3 and C of U is nothing but the cost to arrive from U to the source to the destination, from source to the destination. In the step 2, you have to find what is the distance of the destination node. So that is equal to D of U plus C of U comma V. So there is a small pseudocode given. So Dijkshtra, it is a graph comma source. The input could be the graph and the source. You have to set vertex q for each vertex v in graph. Distance should be infinite. Previous thing should be null. If v naught equals yes, you have to add priority to q, otherwise distance would be 0. While q is not empty, you have to extract minimum of q for each neighbor v of u. You have to relax u comma v. So let's see how this Dijkstra's algorithm by a smarter way.
Good morning everyone. Our team is going to do a case study on the topic of Dijkstra's algorithm. Dijkstra's algorithm is an iterative process which is used in the graph to find the shortest between the vertices. It is different from the minimum spanning tree because the shortest distance between the vertices might not include all the vertices in the graph. It is crucial to note that Dijkstra's algorithm is only suitable when all the weights are positive. This is because the weights of the edges are summed during the implementation of the process.
The algorithm operates by maintaining a set of nodes known as the frontier, which contains all the nodes that have been visited but not yet processed. The algorithm then repeatedly expands the frontier by selecting the node with the lowest weight and adding its neighbor at the frontier. This process continues until the destination node is reached, at which point the shortest path to the destination has been found. Dijkshtra algorithm is guaranteed to find the shortest path from the source to the destination. If such a path exists, however, it is not guaranteed to find the shortest path if there are multiple paths with the same weight.
Practical application of Dijkstra's algorithm. The Dijkstra's algorithm is used in route planning in transportation networks, social networking application to identify connections, in telecommunication networks to establish connections, and in mapping services to pinpoint locations.
Advantages of Dijkstra's algorithm. Dijkstra's algorithm always finds the solution of the with the shortest path. Will always and only focus on the targeted node. Dijkstra's algorithm expands the fewest number of nodes, find the optimal path.
There are some limitations for Dijkstra's algorithm. It performs a blind search which can be time consuming. It can handle negative edges resulting in a graph where the optical shortest path may not be found.
Thank you.